Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate from the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so question 1. A chemistry student needs to standardize a fresh solution of sodium hydroxide. Carefully weighs out 365 milligrams of oxalic acid, a diprotic acid that can be purchased inexpensively in high purity, and dissolves it in 250 milliliters of distilled water. The student then titrates the oxalic acid solution with his sodium hydroxide solution. When the titration reaches the equivalence point, the student finds he has used 83 milliliters of sodium hydroxide solution. What is the molarity of the student's sodium hydroxide solution? Round your answer to 3 significant digits. Okay, so let's first write out the titration of oxalic acid with sodium hydroxide. So they gave us the chemical equation for oxalic acid, which was H2C2O4. And this was reacted with sodium hydroxide, which is NaOH. And this titration produces water. I have to write at a slant now. Plus sodium ions and C2O4 ions. Okay, so now we just have to balance this equation. So let's look at our carbons. They're balanced. Our sodium's balanced. Our oxygens, there's also 5 oxygens on each side. But if we look at our hydrogens, there's 3 hydrogens on our reactant side and only 2 hydrogens on our product side. So I'm just going to put a 2 in front of H2O. So now there's 4 hydrogens, and also there are 6 oxygens on our product side. So if I put a 2 in front of NaOH, that balances out both my hydrogens and my oxygens. But now I just need to put a 2 in front of the sodium ion. So now we have a balanced chemical equation. So the first step is to find the number of moles of oxalic acid that reacted with, or that is just in solution, I suppose. So first let's find the molar mass. So the molar mass of oxalic acid, we would need all the individual molar masses of the atoms involved, so like hydrogen, carbon, and oxygen, but they can just be found on your periodic table. So it's going to be 2 times the molar mass of hydrogen, plus 2 times the molar mass of carbon, plus 4 times the molar mass of oxygen. So the molar mass of hydrogen is 1.01 grams per mole. And for carbon, it's 12.01 grams per mole. And lastly, oxygen is 15.99 grams per mole. Okay, so if we add all these values up, we get a molar mass of oxalic acid, which is 90.03 grams per mole. So now we just have to find number of moles of oxalic acid. So number of moles can be found by dividing mass over molar mass. So we know the mass of oxalic acid was 365 milligrams, but I'm just going to convert it to grams because our molar mass is in grams per mole. So 0.365 grams is the same as 365 milligrams. So now our units for grams should cancel out, and our moles will be our main unit, and you get 4.05 times 10 to the negative 3 moles. Okay, so step 2 is to use mole ratios to find the number of moles of NaOH. So we know that our moles of oxalic acid was 4.05 times 10 to the negative 3 moles. And if we look at our balanced equation, then we can see that 1 mole of oxalic acid reacts with 2 moles of NaOH. So we need to multiply by 2 and we can show the ratio. And now you can see our moles of oxalic acid cancel out, and we're left with our moles of sodium hydroxide, which is 8.1 times 10 to the negative 3. So now step 3 is to calculate the concentration. Calculate the concentration of sodium hydroxide. Okay, so we know that concentration is equal to the number of moles over volume. So we found our number of moles in the previous step, which was 8.1 times 10 to the negative 3. And the volume of sodium hydroxide was given in the question. So he used 83 milliliters of sodium hydroxide to react with the oxalic acid. So I'm going to convert 83 milliliters to liters, just so that our value will be, our final answer will be in moles per liter. So 0.083 liters. And if we divide the two, we get 0.0976 moles per liter. This is our final concentration. So the junior tutor said that oxalic acid is a diprotic acid, and its titration with sodium hydroxide is expressed as the following. Yep. So they found the molar mass of oxalic acid, and then they found the number of moles of oxalic acid, 0.00405. Yep. And then they used the mole ratios to find the moles of sodium hydroxide, and from there we're able to calculate the concentration, and they got the same answer. So this solution is correct.